Hello everyone, welcome to the video for Chapter 4, which is all about electrical systems. So, a couple of things that Rod doesn't really mention. He talks about electricity, talks a little bit about pressure, and relates that to voltage. We're talking about DC electricity, direct current, which is what we have in our planes. We can use things like Ohm's law that says voltage is current times our resistance, or we can rewrite this as the current is equal to the voltage divided by the resistance. The other thing that you want to talk about sometimes is power. So power is current times voltage, or you can rewrite that as substituting here I squared R. There's more than one way you could write this, but these are two ways that you can write it. So most airplanes are either going to have a 14 volt system or a 28 volt system. So 14 volts, 28 volts, and Rod mentions that this gives you a 12 volt battery or a 24 volt battery. And why is the battery voltage less? Well, you have to have more pressure, if you will, in your pump to fill the tire than the pressure you want. Same thing is true with your battery. If you don't have more voltage than what the battery has that's being pumped out, the battery's not going to charge. Right? So something else that he mentions is, he says most airplanes have an alternator. But some airplanes, he doesn't really mention this, have a generator. Now, an alternator makes AC, that's why it's called an alternator, makes alternating current, and that alternating current gets put through something called a rectifier, and that makes DC, which is what your aircraft needs. A generator makes DC directly. So you might say, how come most planes have an alternator instead of a generator? Well, if you fly the Club 1960-172 Alpha, it has a generator because it's old, and it has some downsides, right? So the biggest downside is at low RPMs, nothing happens because you get low voltage. So low RPMs equals low volts. These are also heavier and less reliable. Than an alternator. So things to be aware of. If you have an aircraft with a generator, you are going to worry about that a little bit more. So if you look at the Club trainer at low RPMs, you'll see the little red light comes on that indicates that the battery is being drained, not charged, and that's because you have a generator. So you have to get those RPMs up to at least 1200 RPMs before it really does anything. Old cars, by the way, used to have generators too. So if you went up a hill, the lights would get dim if the RPMs in the car dropped. Both of these, the voltage that they produce is going to vary a little bit, and that's why you have a voltage regulator that takes this voltage and then sets it down to a certain level, sets it down to either 14 or 28 volts. Now, what are some advantages of, say, a 28 volt system over a 14 volt system? Well, the current that I want to run, if I double the voltage, then I can have higher resistance wire, which means smaller wire. So I can have smaller wires are lighter. So that's an advantage. If I look at the power that I need, so the power is the current times the voltage, so I need half the current when I have twice the voltage to get the same amount of power, which again allows me to have smaller wires. A biggest downside of a 28 volt system, you can't jump it from your car. That is a downside. So that's the absolute basics about aircraft electrical systems and the differences between 14 and 28 volts. Let's talk a little bit more about electrical systems. In a typical aircraft, you have your alternator, and that's usually connected through some sort of meter, a load meter or a discharge meter. In this case, it'd be a load meter that shows how much current is coming from the alternator to the primary bus. So all a bus is basically a piece of metal, and you tap everything else off of it. Right? So your primary bus has all this stuff that when you turn the master on, you want to run, things like, you have lights, obviously they're connected through switches, but you'll have stall warning. You'll have other electrical items that you need to run pretty much all the time. That primary bus will be connected often through an avionics master to a avionics bus. So that way you can turn all the radios on and off with one switch, which has a number of advantages. Number one, it saves wear and tear on the individual switches on your avionics. Because if those go bad, then it could be very expensive to fix that. It also makes it easier for you to turn stuff on and off during engine start and shutdown. You might say, why would you want to do that? Well, you might want to do that because you can get a spike in voltage, and you have these nice modern avionics that can mess them up. So there's nothing worse than having your nice modern avionics and all of a sudden you're like, oh, I'm buying more modern avionics because, oops, I left the stuff on while I was cranking the engine or shutting it down. And connected to the primary bus, sometimes again through a meter that's showing you if things are discharging, or in the case of our club trainer, a little light that shows you, hey, current's flowing to the battery. That tells you, is it discharging or charging? That way I know what's going on with my battery. Now a little bit about circuit breakers. Older planes might have fuses, and if you look at our trainer again, it has fuses for all but a few things. Some of the avionics, which were added later, have circuit breakers. Everything else has fuses. When you have circuit breakers, there's two basic types. You have those that are pullable and those that aren't. So typically the ones that aren't pullable are white in color and they're flush mounted. So you'll have instructions in your pre-flight and your before takeoff preparations that say, check all the fuses. Some people will run their hand down the line of fuses, or sorry, breakers, and go, oh, no, none of these are tripped. They're not popped out. They pop out, there's red on the inside, so you can easily see if they're popped. Then there's pullable breakers. They're usually black in color, and they have like a little handle on the top. So if you look at a non-pullable breaker from the side, it looks kind of like this. You know, here's your panel, And the pullable breaker is basically the same mechanism, except for you have this little part that you can pull on. So you can pull it out. You might say, why would I want to do that? Maybe something's malfunctioning and you want to pull the breaker. So that's why you would have a pullable breaker. What kinds of things have pullable breakers? Flaps, electric trim, any kind of a motor is probably going to have a pullable breaker. Your autopilot is going to have a pullable breaker. Often your electric gyros, like your turn coordinators, usually electric, will have a pullable breaker. I think that one is primarily so that flight instructors can torment their students by going, hey, how come your turn coordinator is not working? And they don't notice the big red flag on it that says, hey, I'm not getting any power right now. So those are the different kinds of breakers you might find in a typical aircraft. Now, some people, they don't have something quite as orderly. I was told that the avionics folks claim that instead of having a nice bus for this, for our avionics and our trainer, there was 4 things just sort of hardwired to the back of a switch, which is not a very good way to go. Speaking of wiring, another little tidbit for you, in case you ever, I don't know, built a plane or something. When you buy wire, you can buy solid wire, you can buy stranded wire. Solid wire is not permitted in aircraft. And the reason for that is that if it vibrates, it can flex and it can cold work and then break. But stranded wire is more flexible, it's easier to run. And so flexible wire that's stranded, it flexes, but those little itty bitty strands are a lot more powerful or a lot more robust, I should say, than one big strand of wire. Some other important things to know about electrical systems. We talked about the voltage regulator and how its purpose is to provide the right voltage to your bus. Now, many airplanes have this red split master switch, and it has 2 sides. It has an alternator side and a battery side. Normally you operate with both of them on, kind of like the ignition system. We talked about that before, and we said that normally you want to have both ignitions on. Well, what if there's a problem? Maybe there's a problem with the alternator. Something's failed in a way that it's sucking power from the battery. Maybe there's a short somewhere in this system. So you might want to turn off the alternator side. What if your battery suddenly went bad? You know, they can get things like internal shorts, and they can fail suddenly. It happens sometimes. And you might want to isolate it. So those are the only conditions where you'd want to turn off one side of your master. Now, you might briefly turn off the alternator side of your master if this voltage regulator gets tripped. And this is something that can happen sometimes. If you get a spike or something weird happens, there's a little hiccup, this voltage regulator might say, hey, unsafe, too high voltage, something like that. Let me shut off my voltage. Let me shut myself off. In a case like that, what you want to do is you want to shut off the alternator side, leave it off for a second or 2, and then turn it back on. It might reset this. You know, speaking of resetting things, we talk about the circuit breakers. What do you do if it pops? Well, if it pops, you can try, if it's an essential system, you can try to reset it. If it pops again, leave it alone. Don't keep trying. In-flight fires are not fun, especially electrical fires that might be in the cockpit. So, That's kind of a rule there. So yeah, I've had it happen more than once where this guy is tripped. You just reset it and it's happy again. But yeah, don't be the guy that says, oh, it keeps popping, let me just keep pushing it in. If it's something you don't need especially, just figure it out on the ground. Don't figure it out in the air. Another thing that you will encounter sometimes, some aircraft will have a breaker to the alternator. You might say, why is that? Remember we said that alternators are nice, newer, lighter, etc., etc. Normally an alternator doesn't have permanent magnets because those would be heavy and clunky. So instead of having permanent magnets, it has an electromagnet that the little loop of wire goes and spins through in order for this to produce electricity. Well, sometimes you'll see an AC breaker, a alternator breaker, and some aircraft like the Alaris that I used to fly actually have an alternator field switch. Now in the case of that aircraft, the master, essentially the battery master if you will, is a circuit breaker. Every switch in the Alaris is actually a circuit breaker. So it's a circuit breaker switch. Right next to it is the alt field breaker. So I had a situation once where someone came and they rented an Alaris from my school and they went out and they flew it. They came back and they were super angry. They're like, your airplane failed, your electrical system failed during my flight, it's a piece of junk and I'm really mad, I don't think I should have to pay to rent this aircraft, blah, blah, blah. Well, he was flying with his girlfriend. His girlfriend had taken some pictures, and in those pictures you could clearly see that that alternator field switch was down. So in other words, he didn't follow his checklists, and in that particular aircraft you had about an hour. If you ran everything, you had about an hour's worth of electricity to drive everything before everything would start to go offline. Rod talks about what kind of power do you need for different items. Radios don't take much to receive, but they take a lot more to transmit, something like 5 to 10 times more power. Transponders take a lot of power. Lights, typically not so much. Motors, autopilot motors, trim motors take a lot of power. So, those are some additional items to consider when you're looking at an electrical system in your aircraft. So again, to summarize, when things go wrong, if this trips and suddenly you're not getting anything out of the alternator, try to reset that side of the master and see if it works. That's usually somewhat safe to do. And if a breaker trips, if it's an essential item, you can try it one time, and if it trips again, you're done. Figure it out on the ground with a mechanic. All right, last thing I want to talk about with electrical systems. Many aircraft will have a ground power plug. So if you have a Piper, or basically most things that aren't a Cessna, it'll look like this. It's a round connection, it has a little post in the middle, and you plug a cable in and you can get ground power to start your aircraft. Which, again, if your battery's completely dead, not recommended you go fly with a completely dead battery. It's better to charge the battery and then go fly. So you might have a plug that looks like this, or you might have a plug that looks more like this if you're flying in a Cessna. These are in different places. Some of the Cessnas, they have these up close to the front, up by the meat chopper. A lot of the Pipers are a little bit further back. The Alaris actually had a Piper style plug way back at the tail. So different options for these. So these can be used to start your engine if your battery is too low. One thing you should be aware of, some people will sometimes use these to charge the battery. You need to check your manual for your aircraft, because some of these aircraft actually have a disconnect switch. So there's a little solenoid in here. So if there's any power that runs through this connection, it basically is going to pull a switch open here, and it's going to disconnect the battery. And they do that for a couple of reasons, but this way you won't have any issues with your ground power. Maybe you connect way too much voltage here. I've seen guys that will intentionally connect 28 volts to a 14 volt system so they can get it to start easier. Well, you can also burn up stuff, right? Your starter motor might get fried because you put too much current through it. So you got to be careful with things like that. So that's ground power, and it can sometimes be used to start your aircraft. And that brings us to the end of chapter 4.